Hello, and welcome to this instructional video about finding greatest common factors exclusively using subtraction. So this is a technique known as the Euclidean algorithm. And it is named after its discoverer, who is the same Euclid that you may have heard of in terms of geometry. He was doing his work about 2,500 years ago, and much of it still stands. I'm not going to prove why the algorithm works. The short version is that you can use ring theory, a type of algebra, to demonstrate that the final result has to be greater than or equal to the greatest common factor of two numbers on one hand, and also less than or equal to the greatest common factor of the two numbers on the other hand. If it is both greater than or equal to and less than or equal to, it must be equal to. So the idea is that we can find the greatest common factor of two numbers using repeated subtraction. For example, let's say our two numbers are 221 and 143. Most of us have been taught to do our greatest common factoring by breaking down the factors and looking for those common factors. But we've also been trained to look for factors that are up to about 10, maybe 11, not much beyond that. While one of these numbers does have a factor as low as 11, the other one does not. And neither one are prime. The advantage to the Euclidean algorithm is that it works with absolutely any pair of integers. We can find the greatest common factor of any two numbers, even if it's only one. So that is the big advantage of the two. I say integers. If you have negative numbers, you treat them as positive and look for the positive factors in most cases. So what you want to do is you want to take our larger number and subtract the smaller number from it. In this case, 221 minus 143 is 78. Now we take our lower two numbers and use these two as the first two numbers in another step in the process. That gives us 65. Now we take our 78 and 65. And that gives us 13. 65 and 13 is 52. 52 minus 13 is 39. 39 minus 13 is 26. 26 minus 13 is 13. And 13 minus 13 is 0. Here is where we stop. Once we hit 0, this number that we have is our greatest common factor. In other words, 221 can be factored as 13 times 17, while 143 is 11 times 13. So we subtract the smaller number from the larger. If the difference is 0, we have the greatest common factor or greatest common divisor. So the GCF or GCD, according to your local vocabulary. If not, we take our two smallest numbers and return to step 1. And you might notice that it was only when we got into repeating the 13s that the number on the bottom was greater than the number we had just subtracted. This will be consistent throughout this process. These 3 steps are the steps that you could program a computer to do fairly easily. So if you want to make an algorithm that finds our greatest common factor, these are the steps you program into that algorithm. Now, if you really want to save time, we can shortcut this, because that repeated subtraction is not any different from doing division with remainders. So we could have taken 221 divided by 143, which goes in once, remainder 78. Sorry, I was getting ahead of myself. And then we take our divisor and divide it by the remainder. Gives us a new remainder of 65. Divisor divided by remainder goes in once, remainder 13. And then divisor divided by remainder goes in 5 times, remainder 0. And when our remainder is 0, our divisor is the GCF. So this is another way that we can program it. And it's actually a little bit faster even if you're doing it by hand. It's not just using subtraction. So we are still using some division. So if you're learning this for the first time and you're more comfortable with subtraction, you want to use the first version. If you've already gotten familiar with it, you're comfortable with division, and you're just looking for ways to find the greatest common factor of uncomfortably large numbers, or you want a computer to do it for you, well, that's when you go to the second version in the algorithm, where you divide the larger number by the smaller number. And now, if the remainder is 0, then our divisor is the GCF. If the remainder is not 0, then we take the remainder and the divisor and return to step 1. So this is a more convenient way to find the greatest common factor of any 2 numbers whatsoever.